wishing well. Don't ask me, I'll never tell.
Here we go, Chapter 17, Thermochemistry. In this chapter, we're going to talk about the flow of energy and heat, and something that's called enthalpy, and we're going to do a lot of calculations with the heats of reactions. Okay, so here we go. We have all heard of energy before, and the definition that we can have for energy is the capacity for doing work or supplying heat. Unlike matter, energy doesn't have mass and it doesn't have volume. That, remember from a really long time ago, that was the definition of matter, something that has mass and volume. Energy has neither of those. The way that we know that energy exists is because of its effects, what it does. So for example, like when you move your car, that's because your fuel, gasoline or whatever is in your car, is supplying energy so that the car can move. So we have a lot of stored energy, we have a lot of not stored energy. The term thermochemistry is the study of energy changes that occur during chemical reactions and changes in state. That means state of matter. So every substance has a certain amount of energy stored inside of it, and we call this stored energy chemical potential energy. And this all has to do with the kinds of atoms that are in the substance and the arrangement of the atoms, because different arrangements will have different amounts of energy. So during a chemical reaction, a substance is transformed into another substance and with a different amount of chemical potential energy. So, for example, gasoline in your car. Gasoline, before you put it into your car, is energy that's waiting to be burned up to use to propel your car forward. But as the energy is actually working, and as it's working on the engine becomes very hot. So that means that heat is produced. So heat is another form of the energy that's being changed. So, just so we all know, energy changes occur as either heat transfer or work, or a combination of both. So what is heat? Heat is the energy that transfers from one object to another because of a temperature difference between the objects. And in our calculations, we are going to symbolize heat as a Q. So if you look over here, that is a Q, not a G. Okay? One of the effects of adding heat is increase in temperature. Heat and temperature are two different things, okay? But you can increase temperature as a result of having more heat. And whenever we have heat flowing, because heat is energy and energy can flow, it always goes from hot to cold, warmer to cooler, okay? So up here in the picture, it starts out at hot and the heat travels to the cold. Never the other way around, only hot to cold, okay? If they remain in contact, so the two objects are touching, then they are going to continue to have the heat flow through them until each object is the same temperature. And we can actually use that type of thing with a lab that we're going to do later, okay? But if they keep touching, they're going to go to the same temperature. So what is temperature compared to what is heat? They are sometimes used interchangeably, but that is not true, okay? Temperature is a measure of the random motions of the components of a substance. So it has to do with like the kinetic energy, the movement. And heat is that flow of energy due to a temperature difference. So temperature really measures heat flow. So they're not the same thing. So if we have something that's 25 degrees Celsius, that does not say that that means it has 25 joules or something of heat. They're different, okay? So make sure you know the difference between temperature and heat, and please do not use them interchangeably, because they can't be. So some terms that we need to know. When we're studying energy changes, we have something that's called the universe, and that is the portion of the area you are studying, okay? So yes, we could talk about our big bad universe here, but we could have the universe being just what's inside a beaker. We could have the universe being what's inside the test tube, maybe in a car, in the planet, anything like that. The universe is what you are studying, what you're looking at, Okay? And so then the system is the part of the universe on which you are focusing your attention on. So we want to pay attention to the system. And the surroundings are everything else in the universe. So everything that surrounds the system is counted as a surrounding. And for us, the surroundings will be everything immediately located around the vicinity of the system. So what's like almost in contact with it, what's very close to it. So we don't have to have like the big whole universe as a part, galaxies and stars and all of that as a part of our surroundings. It's just going to be like the air next to it or something like that. So this nice picture, if you want to draw this, this symbolizes the system is in the middle, and this is what we are paying attention to. And the surroundings is everything immediately following that on the outside of the system. Okay? So we're going to have to be able to know what surroundings are and what the system is in our problems this chapter. So these are very important information, words, vocab terms you need to know. Okay, the law of conservation of energy. Thermochemistry, one of the major goals is to study the flow of heat between the system and its surrounding. Where is that heat going? Okay? And so, just like the law of conservation of mass, we have the law of conservation of energy that says that in any chemical or physical process, energy is neither created nor destroyed. So, however much you start with means that's what you're going to end with. It may be in a different form, but the energy remains unchanged. Conservation. Okay, so direction of flow. Whenever we're figuring out where this heat is flowing, we have to always look at it from the system's point of view. So what we're focusing on, the center. Okay? Whenever we have heat absorbed from the surroundings, that it means it's coming into the system, it's gaining heat, then we call that an endothermic process. So the surroundings are losing the heat and the system is gaining the heat, is endothermic. The opposite is exothermic. When the system releases heat into its surroundings, that'll be exothermic. So if you ever see the word absorbed, that means it's endothermic. That's your key word to tell you it's endothermic. And if you ever see release, that is your key word to tell you it's exothermic. Okay? That's important in a little bit. Next, when heat is negative. When heat is negative, remember heat is Q. This is just an algebraic equation, don't worry about it. But when heat is negative, that means that the system's energy decreases because it's losing the energy. It's popping out. I would go ahead and draw this in that nice big spot I left you. Okay? So just you could do a circle, you could do a box, whatever. But the inside part is the system which we're studying, and the energy is leaving the system. So the system is losing energy. The energy is decreasing. And the surroundings are everything else around it. And when this happens, when Q is negative, we call that exothermic. Because the energy is being released. Okay, so then the opposite, when heat is positive, that means that the system is gaining energy. So this time, if we have our system in the middle and the surroundings on the outside, the energy is going into the system. So therefore, it's increasing in energy. And when it's increasing in energy, we call that endothermic. Again, I would draw something like this because it might be a test question. Just so you're aware. Okay, so we only have one part left. This is our one example for the day, where we're able to recognize an exothermic versus an endothermic process. Okay, so on a sunny winter day, the snow on a rooftop begins to melt. As the melted water drips from the roof, it refreezes into icicles. Hopefully, I'm sure we've all seen this so far, probably even this year because we've had a crazy winter. Describe the direction of heat flow as the water freezes. Is this process endothermic or exothermic? So, to figure this one out, there are three steps that we're going to take to figure out our final answer, okay? So the first step, we are going to identify what is the system and what is the surroundings, or what are the surroundings. Once we identify those, then the next step, where is the heat flowing to? What is that direction? Is it going from the system to the surroundings or the surroundings to the system? Okay, so the next step will be determining the direction of the flow. And then the last step, depending on that heat flow, then we were able to tell if it's exothermic or endothermic. Which is what the problem is asking for. So good thing we're solving for the right answer. So step 1, identify the system and the surroundings. Okay, so we have water that has been melted. The snow melts, and so then we have water, and it's dripping from the roof, and then that water refreezes back into icicles. Okay, so this whole big process is having to do with the water freezing and melting and freezing and melting. Okay, so then that means that we're going to focus on the water. So the water is our system. So we're focusing on the water. And we know that heat is moving back and forth because that's kind of what's happening when you melt or refreeze or melt or refreeze something. So the surroundings are going to be the air around the water, because it's probably a little bit warmer than normal because it is a sunny winter day, but it's still pretty cold if we have some snow and it's refreezing and melting and refreezing. So the surroundings will be the air around the water or snow or icicle, whatever it is. Okay, so step 1 taken care of. Step 2, the direction of the flow. So when the water is freezing, the heat energy, if you have more energy and less energy, water has more kinetic energy than ice because water has more movement, and if it has more movement, that means it has more motion, more kinetic energy. Ice, it's a solid, it stays, it's rigid, it's going to have less energy, so that means less heat. Okay, so if we're comparing our system, the water, to the surrounding, the air, the heat is going to flow from higher to lower concentration. So if the water has more energy, more movement, we said that means it has higher energy, and the air has less energy. So the heat is actually going to be escaping the water to go into the air. So that means the flow will go from water to air, from the system to the surroundings. And finally, step 3, our final answer that we need to know, exothermic or endothermic. Well, remember, if the energy is leaving the system, which we said the system is water, if the energy is leaving the system, so the system's energy decreases, we call that exothermic. Okay, so then we have deduced that the process is exothermic. So we're going to stop now for the day, and we're going to we're going to do assignments number 1 for chapter 17, and we can do numbers 1 and 2 like this. Please, please, please do step 1, identify system surroundings. Step 2, figure out the direction of the flow, and then because of that, then finally you can figure out if it's exo or endothermic. All right? Catch you on the flip side.
Hey, I just met you.